Welcome to Super Entrepreneurs Podcast. Today we have with us Don Hoffman. How are you, Don?
Great. How about you, Shaid?
Doing wonderful. Thank you so much for asking. So tell us more about what you do, please.
Let's see. I'm a professor emeritus at the University of California at Irvine in the Department of Cognitive Sciences, and I study human visual perception and evolution of sensory systems, so evolution by natural selection. And I'm also interested in studying consciousness and its relationship to brain activity and physics. So having a lot of fun.
Oh, that's amazing. So consciousness is a kind of a pretty big topic, right?
Absolutely. And it's now a scientifically respectable topic. When I was a graduate student, you couldn't talk about consciousness. So it wasn't respectable. But now it is.
Even 5 years ago or so, right? Wasn't it still not really talked about? Or was it?
Well, among academics, I would say it started taking off in the 1990s. So academics began to take this quite seriously. It may not have gotten into the popular consciousness, but the research was really going on. I was a graduate student in the early 1980s, and back then it wasn't really okay to talk about consciousness if you wanted to be taken as a serious scientist, serious cognitive neuroscientist. But Francis Crick was largely responsible for this switch, because Francis Crick, who won the Nobel Prize for his work on DNA with Watson, the discovery of the structure of DNA, he wanted to not only unravel the mystery of life, he wanted to unravel the mystery of consciousness. And so he said, it's time for science to get serious about consciousness. And when Francis said we could do it, then a lot of people jumped on board.
Yeah, of course. One of the biggest questions is it physical? Is it in our brain, or is it in the air? What are your views on that? We don't have answers yet, but
I have a lot of good friends and colleagues who are studying this problem. And I can tell you that the general approach, I would say 98%, 99% of my colleagues who are studying this are physicalists. So they assume that space-time and physical objects and particles and matter and brains are part of the fundamental reality, and consciousness is a latecomer in the universe, and consciousness somehow emerges from brain activity. And these are, again, my friends and colleagues. They're brilliant people, and it's natural that they would do this because the physicalist framework has been so successful in science for several centuries. But on this particular problem, it looks like physicalism has run into a hard wall. There's not a single specific conscious experience that any of their theories can explain right now. So there's a lot of scientific theories out there: integrated information theory, orchestrated collapse of quantum states of micro.
Give us some examples.
So integrated information theory says that consciousness somehow is the product of the right kind of causal computational architecture. So if you have the right kind of causal structure, so it could be neurons, it could be computers, it could be something else. If you have the right causal architecture and the right, what they call Q shape and so forth, then you will have some specific conscious experiences. But if you ask them, okay, so what is the specific causal architecture that must be the taste of vanilla? They can't give you anything. So there's not a single specific conscious experience that they can say, this is the physical or...
So they can't pinpoint.
They can't pinpoint one. And that's true of all of the physicalist theories. None of them can explain even one specific conscious experience.
Wow.
So they're shooting zero for 100.
That's huge.
Yeah, it's a huge problem, and they know that it's a problem.
It's exciting.
And it's pretty exciting. And so my approach, which is what you asked, so I needed this context to talk about my approach, because my approach is different. I'm proposing that consciousness is not a latecomer in the universe, it's fundamental. And that space and time are not really the fundamental nature of reality. They're just a virtual reality headset that some consciousnesses use to interact with other consciousnesses. So it's a complete change. Instead of saying space and time and physical objects in space and time is the fundamental reality, which hasn't been able to work to explain consciousness, I'm saying let's start with consciousness as the fundamental reality, when
Yeah.
space and time is just a little headset or a data structure that consciousness is used to simplify their interactions with other consciousnesses.
So
And that seems to be panning out pretty well, because it seems like we can boot up space and time from the theory of consciousness, whereas starting with space and time and objects, we can't boot up a theory of consciousness. So we can go into that if you want.
yeah, I would love to go into that. Yeah, for sure. And then you've been doing a lot of studies on this, right? Research on this as well. So you could probably share some of those examples as well.
Right. Yeah, I've been working on this with my collaborators for many decades. And so the approach that we're taking is we start with a notion of what we call conscious agents. And conscious agents are not inside space and time. They're just, they have conscious experiences, and they affect the conscious experiences of other conscious agents. So it's like a big social network, like the Twitterverse. And it's a big
Are
social.
we talking about like just a figure of speech right now?
Yeah, as a metaphor to talk
Metaphor.
about,
Okay.
it's all mathematics,
Got it.
but I'm using
Okay.
metaphors to
Got
give
it.
you the
Yes.
gist of the math.
Perfect. Yes.
So it's an abstract mathematical network, and so it's all network information theory. If you're going into the math, it's a lot of network information theory. So people who are working on internet and so forth, distributed information systems, would be right there. They'd understand some of the math that's going on here. But the idea is that if we start with conscious agents and just their experiences and probabilistic relationships among their experiences, we can boot up space and time. And so I should say why I'm trying to do that and what would the physicists say, right? Space and time is the domain of physicists. So what is a cognitive scientist doing in their playground, right?
Yeah. Hope no fights break out, but
yeah, of course, when it comes to physics, they're the experts and not me. But
yeah.
what the physicists have been saying is, for several centuries, they've assumed that space and time, or the combination space-time, since Einstein's space-time, is the fundamental nature of reality. And it's been a fantastically profitable and successful framework. But in the last few decades, within the last, say, 20, 30 years, physicists have been starting to say space-time is doomed. That is, space-time is not the fundamental reality in the physical world. It can't be. And the arguments are actually quite straightforward. When you bring quantum field theory and Einstein's theory of gravity together, it turns out that space-time basically falls apart at 10 to the minus 33 centimeters. It has no operational meaning. The very notions of space and time have no operational payoff for you at that point. There's nothing you can do with them. If you're interested, I can explain why the physicists say this. What is the problem? But if we don't want to go there, I'll just say that they're saying space-time is doomed. It's at what they call the Planck scale, 10 to the minus 33 centimeters, 10 to the minus 43 seconds, that space-time is no longer a useful framework. It can't do anything for you. And so now they're looking for structures beyond space-time. And they just in the last 10 years, they found some. So this is brand new stuff. In the last 10 years, physicists like Nima Arkani Hamed and his collaborators, Benincasa, and there's quite a few of them. I won't go through the whole list, but a number of great physicists have found several structures beyond space-time. So these are not like structures embedded in, curled up in tiny dimensions of space or something like that. This is space-time is this 4-dimensional, or if you're a string theorist, 10 or 11-dimensional structure, and completely outside of space-time, prior to space-time, are these new structures. And these new structures could have a lot of dimensions. They could have trillions of dimensions, something called the amplitude-hedron. And for example, it is one of the structures they found on the cosmological polytope. So these are structures that could have lots and lots of dimensions, far more than space-time. Space-time is a trivial projection of these much more complex structures.
Wow.
But
that's not proven yet, right? Those are just theories again.
It's all mathematics at this point, right?
You can't
go in a spaceship and go see these structures, right?
No,
because they're outside of space and time.
Based on math.
That's all based on math. But here's the reason why the physicists are pretty excited about these structures. First, they know that space-time can't be it. Space-time is not fundamental, so they know that. Second, they're interested in you probably have heard about these particle colliders, like the Large Hadron Collider near Geneva at CERN, where you take particles moving at near the speed of light and just smash them into each other, and you see what happens. You're trying to figure out what's the structure of protons and so forth. It's very much like trying to understand how a car is built by taking two cars and smashing them together and see all the parts that fly off,
Reverse engineer.
and then try to reverse engineer. It's a lot hard work.
Yeah.
And what they found is they have hard data now from tons and tons of decades of these studies. They know the probabilities for different kinds of events. If two particles called gluons smash into each other, and say four gluons go spraying out in certain directions, they can tell you what the probability, they call the amplitude, but the probability for that happening. And so for all these different collisions and all the products that can come out, they can tell you what's called the scattering amplitude. The probability, that's what you would see in this collision. But when you do that computation inside space-time, it's like the one I mentioned, 2 gluons in, 4 gluons out. It's hundreds of pages of algebra. It's a real mess if you do it in space-time. But when you do it with this new structure outside of space-time, 3 terms, you can do it by hand. And so all of a sudden, the math gets easy. And also they see new
That's
symmetry.
a good indicator.
It's a very good indicator. Plus, there are new symmetries that turn out to be true of the scattering events, but you can't see it in the space-time representation, but you do see it when you let go of space-time. So the math becomes easy, and all of a sudden you see symmetries that are true that you couldn't see inside space-time. So they know that they're on to something, and they can now compute all of the scattering amplitudes for all spins and masses of particles with these new structures outside of space-time. So it's not just that space-time is doomed, it's that they found something deeper. They've been able to go beyond space-time, and they found the amplitude-hedron and cosmological polytope, but the deepest structure they found is something called a decorated permutation. So it's
all these big words, they're going over my head, but at least I'm getting some of it for sure.
Well, the permutation is like shuffling cards, right? So if I have 52 cards, I could have the ace first, then the king, then the queen. But if I shuffle them, maybe I'll have a 3 first, and then a jack. And so those are just permutations, right? So permutation is pretty everyday kind of stuff. Every time you shuffle cards, you're changing the permutation of the cards. And so it's stunning to the physicists, and even and of course to us as casual non-physicists. Why should permutations have this deep place outside of space-time and somehow code for all these scattering events? They code for particle scattering in space-time. So that's a big head scratcher, because it's only been in the last 10 years that they've discovered that these they're called decorated permutations because they're like card shuffles, but there's a slight technical twist. It's a pretty small technical twist. If you want, we can go into it. But anyways, so they're stunned about that. And so what we've done is we've shown that our theory of consciousness, our conscious agent dynamics, it projects down to these decorated permutations. So basically, we have a theory in which consciousness is fundamental outside of space-time. And it's a very complicated
seeing that now.
Network dynamics. But now we found that it projects down to these decorated permutations that the physicists have found beyond space-time. And the physicists have said, if you can give us decorated permutations, we can give you scattering amplitudes in space-time. So that's what we're up to. I can now start with a theory of consciousness, project it down to these permutations, and now we can go into scattering amplitudes in space-time. So that's what we're up to now, which is starting with consciousness and predicting particle events in space-time. So the idea would be that consciousness is fundamental and creates what we call particle interactions as a projection on a trivial interface. So it's this trivial representation.
What does this mean, Don, for us for the future, now that we're looking at outside of space-time, right? So there's obviously a lot of work to do, but what does this mean for us like human beings? What will that explain to us in the future?
For us as human beings and also as entrepreneurs, because every time we get a new breakthrough in science and technology, then all sorts of new technology comes up. So for example, think about space and time now as not the fundamental reality. It's just a headset, like a virtual reality headset that we're wearing. And all of our science has only been studying this headset for centuries. but we learned the tools of science studying the pixels in our headset. Now we're taking the headset off. Just in the last 10 years, science is now using its tools and saying, that was just a headset. What's on the other side of the headset? Once you get outside the headset, you start to be able to explore the software that's driving the virtual reality game in the headset. Imagine you're playing Grand Theft Auto, right? And a VR version of it, and you're a wizard. So you've got your car, your steering wheel, you see a Porsche on your right and a Ferrari on your left, and you're racing them and so forth. So you're just using the VR headset interface to play the game. What you're really doing, of course, is toggling some voltages in some supercomputer, right? So there's millions of voltages that have to be toggled in an exact, precise pattern every second, millions per second. That's what you're really doing, but you don't have to see that. You're just turning the steering wheel and so forth. Suppose that you're a wizard and you beat everybody at the game. That's great. But suppose you're the software engineer who wrote the software and knows the software. Then you can take the gas out of the tank of the wizard's car. You can give him a flat tire. You can change the geometry of the roads. You can change the colors of the cars. You can do anything you want because you're not stuck in the headset. You're the software behind it. So that's where science has moved. We've been only wizards of the headset. For the first time in the last 10 years, we're starting to see the first layer of software behind our space-time headset, which means, for example, in the VR Grand Theft Auto example, if I was the software engineer, I could beat the wizard by simply making my car move 20 miles instantly, because I can do that. I'm not stuck with going through the VR world. I can play with the software. Now my car is 20 miles ahead of the wizard. Good luck catching up with me. So the kind of software, the kind of technology that could come out of this is, for example, right now, if we wanted to go to the nearest galaxy, our nearest galaxy is the Andromeda Galaxy. It's 2.4 million light years away. It takes 2.4 million years going at the speed of light to get to our nearest neighbor galaxy. Okay? Good luck. You and I aren't going to see it if we go through space-time. However, once we understand the software that's creating our headset of space and time, we won't have to go through space-time. We can go around space-time. We can just go there directly. So we won't need rockets and fuel and so forth. We'll just understand the software well enough to warp ourselves over there. So so the technology for entrepreneurs, the technology is going to make everything else we've had so far look like firecrackers.
Wow. And are you working on something on these lines when it comes to entrepreneurship?
We just had a paper published this week. It's accepted, and it's going to be out probably next week. So it's been accepted.
What is that?
Where it's at the journal called Entropy. And that's the journal, and the paper is titled Fusions of Consciousness. And what we do is, in this paper, we show how this network of conscious agents and their dynamics precisely projects to the same decorated permutations that the physicists have found. So that in this paper, we show here is how the software gets projected into space-time. So that's the first step. Now it's the question, okay, we just have the link. Now we have to understand all the details of the software and exactly how it controls all the mass and momentum and velocity and spin and so forth of basic particles in space-time. I'm starting with those because they're the easiest thing, right? The basic particles are the easiest thing to start with. Eventually we'll get to more complicated objects like brains and bodies and so forth. But the particle physics, you might say, that sounds really hard. Why do you start there? We start there because it's the easiest thing. It's the simplest thing. It's what we know best. Once we get that bridge, then we can work our way up to protons. So you have to start off with protons, leptons, and quarks. Those are the fundamental things, the easiest thing. Yeah. Then boot up to protons and neutrons, and electrons. Well, electrons are part of the leptons. But then get to atoms and molecules. So we have to work our way up. So that's what I'm working on right now is the precise mapping of the properties of these elementary particles of the standard theory of physics, the bosons, leptons, and quarks, their spins and masses and so forth. So that's our next step in understanding the software. But the technology could be truly stunning, completely game-changing. In terms of the
So
personal side of this, right, it completely changes our conception of who we are, right? When most of us have thought of ourselves as we're these tiny, fairly weak physical bodies inside this vast universe. The universe is 13.8 billion years old. Life took who knows how many hundreds of millions or billions of years to emerge. And then consciousness in the standard story somehow emerged after that. And we're a flash in the pan. From that point of view, we're basically nothing. We're accidents of this long 13.8 billion year of space and time and matter. And eventually will be extinguished because the universe will eventually perish. It will either go in a big crunch or entropy death.
and Don,
So, yeah.
so when we're looking at this, and for example, when we make consciousness fundamental, right? So does that correlate or explain the double split investigation that they have done in the past, and some of them are still doing the double slit experiment? So could you talk about the relation between the two?
Yeah. So quantum theory has this remarkable set of predictions that things in some sense aren't well defined until they're measured. And so the double slit experiment is one of the experiments that sort of pushes you in that direction. And it does follow from the kind of work that I'm talking about, these conscious agent networks beyond space-time. And the idea is that not only does space-time arise from these deeper structures that the physicists are finding, so the amplitude hedron and the decorated permutations, physicists are showing not only does space-time arise, but also quantum theory arises. So quantum theory and space-time arise together from a deeper structure that far richer than space-time or quantum theory. So quantum theory is not fundamental here. Quantum theory is also an interface description. It's a headset property, not a property.
Connection of the headset, right?
Yeah, yeah. So there's a much deeper story than quantum theory. And the reason we get the weirdness of quantum theory is that quantum theory is showing us is that basically what it's showing is that space and time and physical objects are just our headset, and particles only exist when you look, just like with you have a VR headset and I'm playing Grand Theft Auto. I look over and I see a red Ferrari. The thing I'm really interacting with is a supercomputer, right? If you looked in that supercomputer, you would find no red Ferraris in it. There are no red. So where is that red Ferrari? It only exists when I perceive it. When I look, there's the red Ferrari. As soon as I look away, there's no red Ferrari anywhere. Now I'm seeing, say, a green Porsche over here. And that green Porsche only exists when I look. That's what quantum theory is about. Quantum theory is telling us that a particle, so this is what the physicists who won the Nobel Prize in 2022, so they just got their Nobel Prize in December, for this thing, they showed experimental evidence for the claim that local realism is false. And local realism, yeah, that's right. And local realism being false is the same thing as what I'm saying. I look over there, the red Ferrari exists when I look, and it doesn't exist when I don't look. If you claim, oh, but there really is a red Ferrari and it really is red and it really is going 150 miles an hour when I'm not looking, that turns out to be false, right? Because there is no red Ferrari. And that's what quantum theory is saying. For an electron, you say, of course, the electron has
Who
a position.
won the Nobel Prize? Sorry.
Clauser, I think there's three guys. He'll come to me, but one of them's like Clauser. Okay. So three guys won the Nobel Prize. All three of them had done research over the last several decades where they did careful experiments to show that effectively local realism is false, that there is no such thing as the position of the electron or the momentum of the electron when it's not observed. It gets a value of the momentum in the active observation, and then it doesn't have a value when you're not observing. Just like the Ferrari is red when I look, and the Ferrari is not even there when I don't look. So that's the connection between what I'm talking about and quantum and the double slit experiment. But quantum theory itself, all the weirdness of quantum theory is really just saying the physical world is not the truth. It's just a headset. You render it. So to make it really clear, the moon only exists when you look. It doesn't exist when you don't look. Every time you look, you'll see the moon, and others will see the moon. And if they look when you're not looking, they'll see a moon. But it's just like in Grand Theft Auto. You're playing a multiplayer game around the world, right? Everybody's got their headsets on. And so I look over and I say, is there a red Ferrari to my right? And then my friend in China says, oh yeah, I see the red Ferrari on your right. And then my Italian friend says, oh yeah, and watch out, there's a green Porsche on your left. And I look over, oh, you're right. Why are we're all acting as though there really is a red Ferrari that anybody can see and a green Porsche that anybody can see? But it's just because there's software completely outside of our headsets that's coordinating everything so that I render the red Ferrari and render the green Porsche when I look, and you do too. So this is all a headset. And basically what quantum theory is telling us is that we're rendering on the fly and there's a coordination. And so now the physicists are saying, okay, what's beyond the headset? And they're finding decorated permutations. And so then I'm saying, on decorated permutations, we can show that our theory of consciousness projects down to decorated permutations. That was new math. So our paper, that was a new mathematical result, that we could take Markovian dynamics, any Markovian dynamics, and project it down into decorated permutations. So that was, I think, a new contribution to mathematics. So that now says, okay, we have this network of conscious agents that could be the first real layer of software beyond space-time. And once we study it, watch out, the technology is going to be a mind blower.
Wow. Make sure you get in touch with me when that happens, if you're around. So that's great, Don. Can you share with us what you feel your innermost superpower is that got you to this point in life?
I take it that we're not just objects in space-time, that we really are fundamentally consciousness. And my own view right now, personally, is that there's one consciousness, one incredibly intelligent consciousness. And it takes on different avatars. It has the Don Hoffman avatar, the Shahid avatar. Every person is an avatar in this VR game, a space-time VR game, of the one deep intelligence. And in some sense, so it's not that there's anything special about Don Hoffman. Don Hoffman is just an avatar. If I'm in the Grand Theft Auto VR game and I'm a wizard, if I point to the avatar of my avatar in the seat of my ride and say, that's the avatar is really doing all this wonderful stuff. No, the avatar is just an avatar. It's not really who you are. You're not in the game. The person that's really playing the game is not inside the Grand Theft Auto VR. In some sense, the whole Grand Theft Auto game is inside the head of the player, right? You're the one that's rendering, you're the one that's making the Ferrari when you look, and
Got it.
What we are is fundamentally this one consciousness that I think is infinitely intelligent, unlimited intelligence. But it's nothing special about Don or Shahid or any. These are all, put it this way, we're all special, but equally special. There's nothing, no one's more special than anybody else, because we're all just avatars of the one deeper and unlimited intelligence. And in some sense, all I'm doing and what we're here to do is to wake up to what we...
And the work that you do and the research that you guys are doing is going to bring more clarity and visibility to all this over time. Obviously, a lot of it can't be proven, but as Elise is giving us some mathematical answers that we need.
That's right. And when we start seeing technologies that go around space and time, I think a lot of people will not have problems with believing that there's something real and deep.
That's what I mean, Don. Like, when you get to that point, make sure you contact Super Entrepreneurs Podcast, because we got a huge audience and great lineup of guests that would love to kind of evolve into technology on that side of things, right? Because can you imagine creating something at that level? Wow.
That would be truly stunning.
Yeah.
It's just, when you think about before we really understood electromagnetism, right? So in the 1800s, Michael Faraday in England was playing with wires and magnets and frog legs twitching and so forth, and did all these experiments. And we knew that there was something really interesting going on there, and Faraday did brilliant experiments. And then James Clerk Maxwell looked at all of Faraday's experiments and said, wait, I see some mathematics here. And he wrote down what we call Maxwell's equations. Basically, that launched the revolution that's allowing me to talk to you via the internet live. So all of a sudden, who would have known that playing with magnets and wires and frog legs would lead to a technology such that we could talk? I don't even know where in the world you are. So as far as I know, you could be on the other side of the world.
Look what it opened up.
It opened up.
And in the headset.
In the headset. So once we go outside the headset and we open up the possibility of going around space-time,
it's a whole universe.
But then the thing is that it won't just be about this headset. Once we understand this, we can just start exploring new headsets. Why should we be stuck with a 3 dimensions of space, 1 dimension of time world? Why not rejig the software such that now we can perceive in 20 dimensions and perceive whole new dimensions of color?
Go into different dimensions.
That's right.
Yeah.
Completely new dimensions.
Great, Don. This has been a wonderful conversation, my friend. I can hear the passion, and I can tell that you can't wait to wake up in the morning and get into this stuff, because I also find it fascinating, because to be honest, like, we don't know 95% of what we are, what's going on. Science is working really hard to bring answers and visibility, and you're part of that, right? So I have a high regard of respect for you and what you do. Continue, keep in touch. If you come across something interesting like that, please share it, send me an email. I'll connect with your social media as well. And if you have anything else to share in the future, let us know as well. We would love to see how we can support. And again, thank you so much for coming on our show today.
Okay. Thanks a lot, Shahid. Take care.
No problem. And audience, thanks again for joining us. Don's information will be in the show notes. Get in touch with him. Read up on this. If you have never heard of this before, what's going on and what does it have to do with entrepreneurship? There's a lot to do with entrepreneurship. So I will definitely look into this. And as entrepreneurs, we always want to be ahead of things, right? This episode is part of that initiative. So hopefully you can see what this is bringing to you and do your own research. Get in touch with us. If you have any questions, get in touch with Don, obviously. And appreciate you being part of the show, and appreciate you guys helping us grow, because without you guys, it's not going to happen. So again, thank you. And thank you, Don.
Thank you.